Every day, we interact with plants and animals that have been selectively bred for specialized traits. Crops bred for taste or disease resistance. Domesticated pets bred for intelligence. Livestock bred for size. Selective breeding predates modern science, but today it's become a remarkable scientific tool for preserving wildlife on a changing planet. In our warming oceans, breeding one unusual animal may be the best way to future-proof marine habitats. Coral that can finally beat the heat. Evolution has shaped coral in amazing ways. Each coral polyp is a tiny animal. They work together to engineer a calcium stone foundation for our planet's most biodiverse marine habitats. They're also masters of symbiosis. The cells within each polyp contain photosynthetic algae. Polyps provide the algae a safe home. The algae give the coral food, and as an added perk, their characteristic bright colors. But reefs today are under siege from rising ocean temperatures. Above a certain temperature threshold, polyps get stressed and eject their colorful algae, a process that has become known as coral bleaching. Without the algae, the coral will starve to death in a matter of weeks. If enough coral dies, an entire reef ecosystem can collapse. Coral bleaching has impacted over 80% of reefs around the globe. And as ocean temperatures continue to rise, the need for mitigation becomes ever more dire. At the Coral Resilience Lab in Hawaii, scientists are tackling the problem by focusing on one simple phenomenon. Not all corals bleach.
In our lab, we do selective breeding. You first have to identify which parents are thermally tolerant, and you can do that by tagging them during a bleaching event. We deem the ones that don't bleach as thermally tolerant.
This selective breeding can supercharge the natural process of evolution, which normally happens over tens of thousands of years. Heat tolerance, like many traits, is variable within a population. It also comes with a slight natural advantage. When ocean temperatures rise, heat-tolerant corals will be more likely to survive and pass down this trait to their offspring. Over many successive generations, and with a bit of luck, heat tolerance can become more frequent. That would be natural selection. In a controlled setting like the lab, scientists take chance out of the equation. By only breeding the hardiest corals with each other, they ensure that the heat-resistant trait gets passed on. And they can push the limits.
We can program it to be whatever temperature we want it. We ramp the temperature up, and then we bring it back down, and we can assess a coral's resilience under that stress test.
When you can increase that trait and enhance that heat tolerance over time in the genes, that's where you're going to see the greatest difference that can make an impact on heat tolerance of the reef overall.
Selective breeding is a low-tech but effective tool. Corals are joining a long list of animals bred in captivity. But unlike the others, these new corals will be reintroduced back into the wild. There, they'll seed a new population that is better able to withstand temperature rise.
We have a tank which has temperatures that's predicted to happen in 2095, so we can even see how the corals are going to do in about 70 years from now.
We get really connected to these corals. We watch them grow and we nurture them. We feel like we're their parents, and now we're their grandparents.
They may be bred in the lab, but the resilience of these corals is natural. They just needed a helping hand. Explore these stories and many more from Wild Hope by visiting wildhope.tv or watch the full collection now right here on PBS Nature on YouTube.